Hello everyone and welcome to The Explainer. Today we are tackling an absolute cornerstone of the Cambridge 9618 computer science syllabus, and that is mastering the NAND gate. Now you might be thinking, oh, I already know the symbol and the truth table, I'm good. But hold on, because decoding the symbol, the function, and the truth table, that's literally just the starting line. It turns out by looking closely at examiner expectations and theoretical frameworks, we can move way beyond rote memorization. We can actually start thinking like top-tier computer scientists and approach our exam strategy like a martial art, flowing like water and adopting your style to literally any question that comes your way.
Right out of the gate, we have a massive alert here. Directly from the principal examiner, they state, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Okay, this is absolutely crucial. This seems to be the ultimate pitfall that costs easy marks. So many focused learners walk into their exams, look at a really complex logic gate problem, do all the mental math in their head, write down the final binary output, and get it wrong by one single bit. Boom, 0 marks. By completely ignoring the method mark lifeline, it's just so easy to leave points on the table. Today, we're going to find out exactly how to make that thought process visible so you're always protected.
So here is our strategic roadmap for today to ensure you know exactly how we'll deconstruct those examiner expectations. We're going to hit 1. Core principles and connections, 2. The procedural framework, 3. Evaluation and analysis, and finally, 4. Examiner warnings. Let's dive in.
Section 1. Core Principles and Connections.
It becomes pretty clear right away that the foundation of mastering the NAND gate isn't just knowing that it's an AND gate followed by a NOT gate. That won't cut it. The core principles actually demand a rock-solid grasp of precise definitions, causal relationships, and cross-topic integration. Top-performing students don't just memorize things. They exhibit a deeply connected conceptual understanding. They know exactly how a NAND gate impacts data processing, and they can easily transfer that knowledge to totally unfamiliar contexts. Now, before we continue on to the specific expectations, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's look at this. This brilliantly illustrates what Cambridge actually expects from you. Precise definitions and causal relationships are just the absolute baseline. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. So what does that actually mean for us? Well, it means when you're dealing with a NAND gate, you shouldn't be afraid to connect it to the systematic analysis of system architecture, or maybe evidence-based reasoning and hardware design. The exam is testing your ability to see the entire computer science landscape, not just your ability to draw a single logic symbol.
Moving right along to Section 2, the procedural framework.
When looking at how to actually translate theory into actionable problem solving, the Deconstruct, Solve, Evaluate framework completely stands out. Examiners are actively hunting for this exact step-by-step sequence when they grade algorithmic thinking. First up, identify the given information. What are your inputs? Second, break the problem into logical steps. Third, solve systematically. Literally write down the output of every single intermediate gate. Fourth, check for reasonableness. Does this final truth table actually make sense? And finally, step 5, make justified recommendations if the question asks for an evaluation of the circuit. Following these steps ensures your entire method is visible right there on the page.
Now, algorithmic thinking is another massive part of this procedural framework. When we're dealing with NAND gates, we are fundamentally dealing with data interpretation and extracting information from binary representations. This requires step-by-step decomposition. If a question asks you to implement a logic circuit in code, it absolutely demands appropriate data structure selection and efficient code implementation. And we can never, ever forget rigorous testing. Logic circuits or code algorithms must be systematically tested against expected truth tables to ensure complete accuracy.
Let's move to Section 3, Evaluation and Analysis.
This right here separates the average answers from the truly exceptional ones. There is a stark difference between weak and strong comparative analysis. A weak analysis, it just states facts independently. For example, a student might write, Gate A is an AND gate, Gate B is an OR gate. That earns barely any credit. A strong analysis, however, identifies similarities and differences using comparative connectives, and it supports each point with evidence. For example, you might write, whereas both gates are universal, the NAND gate produces a false output only when both inputs are true, while the NOR gate, see the difference there? We are drawing critical conclusions about relative behavior and importance. Stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's get back to it. When NAND gate knowledge is applied to algorithmic design, performing quality checks is essentially mandatory for maximizing your points. We have to be able to evaluate the algorithm's quality by looking closely at time complexity and space complexity. We need to actively hunt for edge cases and boundary conditions. Ask yourself, what happens if all the inputs are 0? What if they fluctuate rapidly? Articulating the specific effects of these conditions on the overall performance of the system is absolutely essential to get top marks.
Section 4, Examiner Warnings.
3. There are 3 specific, reoccurring mistakes that examiners are constantly flagging regarding NAND gate and logic circuit questions. If we can just avoid these 3 traps, we instantly place ourselves way ahead of the curve.
Let's break them down. Warning number 1. Using the wrong formula or algorithm for the given context. It is just so easy to memorize a standard response and try to force-fit it into a question where it simply doesn't belong. Warning number 2. Forgetting to check boundary conditions and edge cases. We actually just touched on this. If the extremes aren't tested, your logic is fundamentally flawed. And warning number 3, which is huge, answers lack specific connection to the question's context. Let me give you an example. If the question is about a chemical plant's safety valve that's controlled by an AND gate, your answer needs to reference the safety valve, not just abstract binary 1s and 0s. Avoiding these traps is literally just as important as knowing the right answer.
And this brings us right back to our golden rule, beautifully summarized here. The method mark strategy. Show you're working. Your process proves your understanding. Even if your final binary calculation goes completely sideways because of exam stress, explicitly showing your step-by-step logic, writing down those intermediate gate outputs and truth table drafts secures those method marks. It acts as an ultimate safety net. Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers.
To help you out under that exam pressure, here is a highly effective, actionable memory hack. To reliably recall the NAND gate symbol and truth table, use a visual story method to encode the data into a narrative. It works like magic. For example, picture an AND gate as a really strict bouncer who only lets people in if both have VIP passes. But that little circle on the end of the NAND gate, the NOT gate, that's a rebel who flips the bouncer's decision entirely. Creating a vivid visual story like this in your mind means you will never blank on a truth table again. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGSE and click that bell. Don't let another exam pass you by.
So, here is a final provocative thought to leave you with. How will you apply this visual story method to map out the deconstruct, solve, evaluate framework in your very next study session? Don't just watch this explainer and move on. I challenge you. Pull up a past paper, find a tricky logic gates question, and immediately apply the strategic framework. Build your visual story, show every single step of your working, and watch your mark potential soar. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. Thanks for joining me, and keep learning.